Okay, so we're going to start with a vertex form. When it's in vertex form, we have, it's a lot like the form that we had in the last chapter, except for this form is solved for y equals. This form is solved for y equals. And when it is solved for y equals, we should have a value in front of the x squared. That value tells us if the parabola opens up or down. It also tells us how wide the parabola or how skinny the parabola might be if it has a vertical shrink or a stretch. If there's no vertical shrink and there's no vertical stretch, what value is that A? Oh, and no reflection. What value is that A? 1. And so you won't really see it because we're not going to write it on there. But if it's anything else, if it's a negative, it'll be a reflection, so it'll open down. If it's bigger than 1, it'll be a stretch, so it'll be wider. Less than 1, it'll be wider. Less than 1 greater than 0. Then the h is exactly how it was in chapter 10, where the minus h gives us the h part of the vertex, the x value of the vertex. And then the plus k, where k is the y value of the vertex, it didn't have a plus before, because k was on the other side of the equation before. So now this is a plus k. You use just k for the vertex. So we look at this first example here, and we write down our vertex. The x value is 3, because it's normally x minus h. So the x value is 3. The k value is negative 4. Because now the k formula is plus k. So you use the sign with the k, because it's on the other side of the equation. So it switches signs from what it was before. Am I making sense? So we'll use the opposite sign for the x, and we'll use the same sign for the y. We did not do axis of symmetry in the last chapter, but you have done it before. Your axis of symmetry is that symmetrical part of the parabola that should go right through the vertex. The vertex is the middle of the parabola. Either side is symmetrical around the axis of symmetry. It is a line, so the equation. We are only doing parabolas that open up or down in this chapter. So this axis of symmetry will always be x equals. And it goes straight through the vertex. So it always is the same as the x value of the vertex. So if you know the vertex, then you know the axis of symmetry. To graph this, you have to know the parent function of y equals x squared. You need to know that. We did that in chapter 1. I'm going to write it up here. I just pick from negative 3 to positive 3 x values. And then I square each of those. So it'll be 9, 4, 1, 0, 1, 4, 9. They're symmetrical around the vertex 0, 0. This is the parent function. I'm going to graph that so you can see it. Anytime you have an a value of 1, this parent function just gets slid around somewhere, wherever the vertex is. Makes it really easy to graph if you know what the parent function looks like. So the parent function from the vertex, you go out 1, up 1, you go out 2, up 4, you go out 3, up 9. You're going out a number and then up its square. That's the parent function. For this function that has a vertex at 3, negative 4, you have two choices. The first choice would be to use your table. And if you're using your table, you're going to take all of your x values and add 3 to them. You're going to take all your y values and subtract 4 from them. So I'll do both ways. This is one method. the X column should be really easy because I add 3 to the first one, and then all of them are just one more than the previous number. So I just like made that 0 and then added 1, 2, 3, 4, 5. On the Y column, they're symmetrical around the vertex. So I subtract 4, I get 5, and then 0, and then -3, and then -4. And then from there, they're symmetric. So it goes to -3, 0, 5. And then I'll graph each of those. So that's one method of how you could graph these. The other method, since there was no stretch, I just think about transformations, translations, and this graph itself is just going 3 to the right and 4 down. So each point goes 3 to the right and 4 down. So once I found my vertex, then I just use the fact that from the vertex it's out 1, up 1, out 2, up 4, out 3, up 5, 9. And then I just move my parabola there. So you can do either method if you want to use the table or if you want to use just transformations. I prefer using transformations if there's no stretch or shrink. I prefer the table if there is a stretch or shrink, because it's hard to do without the table. So the next one, look at that, and you're going to say, ooh, this is in vertex form. Let's find the vertex. Jenna, can you tell me the vertex for question B? Perfect. And then once we have the vertex, we can find our axis of symmetry. Chloe, can you tell me the axis of symmetry? Excellent. So -2, 5. X equals -2 is our axis of symmetry, our reflection line. And then we look at this number outside the parentheses. Is there a stretch or a shrink? No. But the negative does tell us something. What? It's just going to flip down. So instead of going out 1, up 1, out 2, up 4, I'm going to do the same thing when we move down. Out 1, down. Out, down. So I'll go from here. I'll take that parent function. There's no stretch, so I just go out 2, down 4. Or out 3, down 9. And parabolas do not look like these. Make it rounded. Have that vertex, make it rounded. Minimum 5 points graphed. Minimum. Minimum graph 5 points. Minimum graph 5 points. I graph 7. You need to graph at minimum 5. I wasn't really 100% going for accuracy in our last chapter with our ellipses that were like so fun to draw, I think. But now I'm gonna look more at accuracy with these parabolas. How many years have you done them? More than one. All right, the next one is in vertex form. This is vertex form. This is vertex form, so we can find the vertex right away. What's the vertex? 0, 4, right? The x value is not there, so it's 0. That means our axis of symmetry. Carissa, can you tell me that?
X equals 1.
Perfect. Now, if there is a stretch, I'm going to use a table. So since there is a number in front of this x squared other than 1 or -1, I'm going to use a table. So we've got two transformations. We have multiply by 2, and we have add 4. The multiply by 2, is that happening before or after the squared? After the squared. So anything before the squared symbol, anything that happens before the squared symbol is horizontal. Anything that happens after squaring the x is vertical. So I know that this is a vertical stretch. That means it affects the y values. This add 4, is that before or after the square? It's after, so that is also a y change. So how do I know what I do first to my y values? Do I multiply by 2 or do I add 4 first? We always multiply before we add, right? So in my table, I'm going to multiply by 2 next. And then I will add 4. And it should be pretty easy because they're symmetrical, so once you do the first 4, you just, write the same numbers again. So if I'm graphing things like -3, 22, remember you graph the outermost x's and y's. If I'm graphing -3, 22, that's not going to fit on my graph. What could I do? I could change my scale. But I need minimum of 5 points. I've done 7. If I get rid of -3, 22 and 322, I still have 5 points. I'm not going to change the scale. I'm just going to go off my graph a tiny bit. You totally can change the scale if you want to. If I only had 2 or 3 or 1 point that fit on the graph, I'd probably change my scale because I need at least 5. Okay, and then we're on question D. Question D is in vertex form, so we can find the vertex right away, and we can find the AOS from that. Joey, what's the vertex?
6.
Yeah, good. 6, 0. So that makes, Tosh, what's the axisymmetry? Can you repeat that?
X equals 6.
Yeah, x equals 6. Now we do have a 1/3, so that means there's going to be some sort of stretch or shrink. Is this going to be a vertical or horizontal? Does it happen before or after the squared? I can't hear you. Oh, vertical. So it's happening after the squared. Is that what you're saying? So that is vertical. And because it is less than 1 but greater than 0, it'll be a shrink. So this one should be wider. It doesn't go up as fast. I'll use my table. I'll multiply all my values, my y values by 1/3. And then my x values, I will be adding 6. Alright, when I go to connect this, and I'm looking on the left side of my graph, if I only connect to this point, that's not good enough because I want you to connect all the way through. I'm getting nervous because I don't know how wide or how skinny to make this. I feel like I don't have enough points here. So you might, after you find your points, have to find another point. So you can pick any x you want. and plug it into this equation. Who has a suggestion of a good x, something to the left of this one, to plug in here? Ryan, what would you plug in? Why? You got too quiet. Come here. Plug in -2 what?
Plug in -2. I just kind of did it. Just traced this out.
Oh, lines 1, 9. Well, that'll give me -8 squared, which is 64, and then you have to divide by 3. Oh. Would be 100 and, wait a minute, that'd be 81 divided by 3 is 27. So you're thinking really, really hard, and then who just said that over there? I'm thinking more like what she's thinking. I'm thinking, what can I plug in easy? 0. Right? Like if I'm going to plug something in, plugging in 0 is going to be easy. Now, the way you're thinking is really good because you're trying to think of something that can divide by 3. Is that correct? Yeah, and that's a good way of thinking as well. But if you use -3 and then you do -9 and you square it, you're way off the graph, so that one won't work anyway. I'm going to go with 0 first. 0 might be way off the graph, but I don't know. If I'm going to plug in 0, let me show you what your work would look like. You're going to say g of 0. Where did my g come from? Where did that come from? The name of the equation is g of x. So I'm plugging in 0 for x. I write g of 0. That tells everybody looking at my work, I'm plugging in 0 for x. Then I have 1/3, 0 minus 6 squared. So not only are we learning about parabolas, we're also practicing function notation. So now I have 1/3 times -6 squared. So that's 1/3 of 36, which is 12. So my ordered pair 0, 12. Will that fit on my graph? It's close. It's close. Close enough. But now I have like an idea of where to draw the rest of my graph. I'm going to look for accuracy. So if your graph is not hitting the correct places because you didn't find enough points, then you might lose some. Okay? Questions on graphing? Too easy? I should give you first one.
It's the end of the year.
At the end of the year, what?
Like, I don't want hard stuff.
It shouldn't be hard stuff. There should be an easy end of the year now.
I don't know.
Oh, okay. All right, we got 3 more questions for examples today. And these are just find the axis of symmetry in the vertex. And number 1, or A, you should be able to do right now. Because we've already gone over it. See if you can do A. Very good. Remember, ordered pairs, we always write them in parentheses. Scotty, did you get the vertex?
4, 5.
Great. 4, 5. Savannah, what's your axis of symmetry? X equals 4. Excellent. And then, is this going to be a maximum or minimum situation? Do you know what that means?
So it's at the top of the bottom.
So when we look at our parabola, is the vertex going to be the very bottom point, or is it going to be the very top point? Very bottom. So is that going to be a maximum or a minimum? It's going to be a minimum. All right, question B is not in vertex 1. So I gave you some formulas for other forms. You might have to use these if you don't remember them from Algebra 2. And this looks really confusing, but it's not. Cross. So the form that question B is in is quadratic form, the ax squared plus bx plus c. To find your axis of symmetry, you just do x equals negative b divided by 2a. Then to find the vertex. Vertex, the x value is the exact same as the axis of symmetry, so those are the same. Then I have f of the axis of symmetry here. That just means plug in your axis of symmetry into the x to find your y value. That's what this means here. We'll do that together. Our axis of symmetry first. The formula is x equals negative b over 2a. So we do negative 1 over 2 times negative 1. So our axis of symmetry is x equals a half. Then the formula for vertex says, take your axis of symmetry, and then in the equation plug in your x value of 1/2 to find your y value. So that's not the vertex, but that's what I'm about to do. I'm about to do f of 1/2. Okay, so I plugged in 1/2 for my x. I added my like terms together. I defined some common denominators because it's fraction. So now my vertex is 1/2 negative 15/4. Is that going to be a maximum situation where it's the top point or a minimum situation where it's the bottom point? You know, Jade? Do you know? Looking at the vertex will not tell you the answer. It's the leading coefficient. It's the leading coefficient that's going to tell you the answer. It's a maximum because the leading coefficient is negative, so it's going to open down. Now, the reason we took our calculator out is because I want to show you how to find the vertex on the calculator, not because that's how you're finding it, but so you can check your answer. Because this was a fraction, and we're just make sure it was right. So go ahead and take out your calculator, go to y equals, and type in the equation. We're doing question B. We're typing it in. If your window is all crazy, you can hit Zoom 6 to fix your window. If you have any errors, you let me know so I can help you with that. Do I have any errors? So you can tell by the picture now, yep, you were right, it was a maximum. If you're doubting yourself, you can look at the graph. This is a tool to help check your answers. Everything that you want to find about the graph is under calculate. So we're going to do second trace. And under those choices, what do you think we're going to choose? Maximum. We're going to choose maximum. So what am I choosing for? Now it's going to ask for a left bound. And what that means is we need like a boundary line that is going to be x value. Okay. Because when we do these in the future, you're going to have lots of max and mins. So you want the calculator to only look at a specific one. So I want to put a window around just this one. There's only one, but I'm going to put a window around just this one. I want to pick any x that is to the left of that vertex. So we yell out an x. Huh? Negative 1. You know what? I'm going to make it even more obvious. I'm going to do -2. And I'm not going to arrow over to it. I'm just going to type -2, and oops, negative 2, and it shows up down there, and then I hit enter. So just type negative 2, enter. And look, it put the line there at negative 2. Reneen, can you give me the right bounds? How far to the right is it definitely, like, if not past this number? Give me a, it's not how far from here. You're getting way too, like, intricate. Give me, like, a number for sure. 2, okay. All right, definitely in between those two. I'm not, I mean, you can pick any number. Don't make it hard on yourself. Just pick, like, a whole number. Unless it's in between fractions and you really need that. All right, and then from here it says, please make this easier than a calculator. Can you guess it? So I'm going to make a really easy guess. I'm going to say 1. And it gives me the exact, almost, answer. I don't know why the calculator put that 6 at the end of it. It really isn't there. It is really just 0.5. But it has something to do with the window that it's set at. But the answer is 0.5 and then negative 3.75, which is the fraction or decimal value of the fractions that we found. So I've just like confirmed that I did it right. Okay.
Negative 4.99.
Yeah, and it just depends on which calculator you have and like what your something about what the steps set up at. It's hard to explain, but if you've got like negative 4.9999, it is negative 0.5, and that's one reason why we're using this as a tool to check it, not to get our answer. Okay. All right, so we're good on that one. C is the third form, which we are going to use a lot in this chapter, especially with those big ones that I've been talking about. It's intercept form, where we have it factored, and each of the factors will give us one of the intercepts, one of the x-intercepts. So what you're going to do is you're going to find your x-intercepts, and then you're going to average them, because once we have the x-intercepts, the middle is the axis of symmetry. So for C, we take each of our factors, x minus 9 and x plus 15, and we set it equal to 0. And we find that x equals 9 when y is 0, and x equals negative 15 when y is 0. So those are the x-intercepts. So if you had a graph, and you had x is 9 and x is negative 15, and we've got a parabola through those, the very middle is going to be that axis of symmetry. Not drawn to scale here. So I'm going to average those. I'm going to add 9 plus negative 15 divided by 2. And you should get your axis of symmetry at negative 3. Axis of negative 3. No? So you're setting each of these factors equal to 0. So I find that one x-intercept is at positive 9, and the other one is at negative 15. Because that's what makes the equation equal 0. Okay? Did you just have those reversed? Okay. So then I'm averaging this, and I'm going to get negative 3. And my graph is not drawn to scale. And then once I know my AOS, that is the x part of the vertex. So my vertex, I plug in negative 3, and then I do f of negative 3 for the y part. So I'm going to take my equation, and I'm plugging negative 3 for y. I mean for x, sorry, to find y. I did that quickly, but that answer, when you plug it in, you should get negative 3 and then 432. Is this going to be a maximum or a minimum point for our graph? Maximum why? Yes, but why?
Oh, because the thing in front is negative.
Right, this number in front is negative, so that means we are going to have a maximum vertex. Okay, so the assignment we have is a worksheet. And it should be a non-calculator kind of situation, just like we did notes today, with the exception of just checking your answer. You shouldn't be using the calculator to get the rest. All right. How many points minimum should you have for the graph? 5 points minimum, but you might need more if those points are really close together and you don't know what the rest of the graph looks like. Okay.